With adding and subtracting rational expressions, we're going to take what we did with multiplying and dividing, and we're going to take it just a little bit further. So when we have, let's think back to when you guys first learned how to add and subtract with fractions. So if we had 2/3 plus 5/7, what must we have in order to add or subtract these fractions? You need a common denominator. Okay, so let's look at these two fractions for a second. It looks like our common denominator is going to be 21. So that means we have to take 2/3. We have to multiply by 7/7. And then to the 5/7 we have to multiply by 3/3 in order to get that common denominator of 21. So we have 14/21 plus 15/21. Now we can add those numerators and we get 29/21. Okay? Same idea with our rationals when we have variables. So if you look here first, we check the denominators, and those two denominators are the same. So we don't have to do anything to get common denominators. So we're just going to look in the numerator. So we have x squared minus 9 over x minus 3. So just like we did with dividing, let's factor each piece. So all we can factor here is the numerator. We have x minus 3 and x plus 3 over x minus 3. Okay? Now check and see, is there anything that cancels out? And it does. We can cancel this x minus 3. So we end up with x plus 3, but remember your domain restrictions, x cannot equal 3. Even though we canceled it out, it's still a part of the domain restriction. So let's try this one over here. Now with this one, be careful because it says 7x minus. We have to distribute that negative to both pieces in that parentheses. So we have 7x minus 4x minus 12 over x minus 4. Combining like terms, we get 3x minus 12 over x minus 4. Now let's factor that numerator to see if we can't cancel anything else out to simplify. And we can cancel out the x minus 4s. So all we're left here is 3, and x cannot equal 4. Remember, your domain restriction comes from the denominator. We think what value of x is going to make that denominator equal to 0? And that value of x is 4, so we say x cannot equal 4. So let's look at what happens when we don't have a common denominator. It says to obtain a common denominator, we need the least common multiple of the polynomials in factored form. So let's check this out. Look at x squared minus 4. We can factor that into x plus 2 and x minus 2. So now it says list any excluded values, so we can tell that x cannot be plus or minus 2 by looking at all of our denominators together. Now think about this. I like to think of my common denominator by looking at each denominator and saying, what does this fraction have in the denominator that the other doesn't? Well, they both have the x minus 2, so that's good. But this second fraction also has an x plus 2 that first fraction doesn't. So that means we have to take x plus 2 over x plus 2, and we're going to multiply that to the x over x minus 2 before we're able to subtract. Okay? So that second fraction, we don't have to do anything with it right now. So I'm going to come on down just a little bit. So now we've got x squared plus 2x when we multiply these together, minus 8 over x plus 2 times x minus 2. So now we're going to see, can we simplify? So we've subtracted the 2. Now let's see if we can simplify. So we're going to try to factor that numerator. So we need two numbers that multiply to negative 8 and add to 2. So we have x plus 4 times x minus 2 over x plus 2 times x minus 2. So now we can see where these x minus 2's will cancel, and all we're left with is x plus 4 over x plus 2. But remember to list those domain restrictions that we found at the beginning. Okay? So let's try a few more. So if we come down to example 1. Really, that was example 1, but here's an extra one. So looking at these fractions, there's nothing that they have in common in those denominators. So this just means, and I'm going to come up here where we have a little more room, in this first fraction, we have to multiply the numerator and the denominator by the 2x plus 5. And in that second fraction, we're going to multiply the 4x times the 3x minus 1. So we're just kind of putting those denominators together. Okay, so we have 6x times 2x plus 5 minus 4x times 3x minus 1 over, now let's simplify in that numerator. We're going to multiply it out. And the reason I rewrote this is I didn't want you guys to forget that we had to distribute that negative. So let's come up here. We get 12x squared, so I'm distributing that 6x, plus 30x. Now distribute the negative 4x, so minus 12x squared plus 4x over 2x plus 5, 3x minus 1. So when we simplify in that numerator, see, combining like terms, those 12x are gone. We get 34x over 2x plus 5, 3x minus 1. So think of your domain restrictions. X cannot equal negative 5 over 2 or 1/3. Okay? So maybe you want to pause when you turn the page and see if you can try number 2 by yourself. All right, number 2. Let's factor each of those denominators. We get x times x minus 2. Then we have x minus 2 times x plus 2 for that second fraction. So now think about this. Let's highlight what they have in common. They both have the x minus 2, so that's good. But this first fraction is missing the x plus 2, so we need to multiply that one by x plus 2. And that second fraction is missing the x, so we're going to multiply it by x in the numerator and the denominator. So let's start rewriting it. So we have 6 times x plus 2 minus 1 times x over x times x minus 2 times x plus 2. So let's start simplifying in that numerator. So if we distribute the 6, we have 6x plus 12 minus x over x times x minus 2 times x plus 2. Combining like terms, we get 5x plus 12 over x times x minus 2 times x plus 2. And there's nothing we can do here to factor that numerator and try to cancel out, so let's just list our domain restrictions. So x cannot be 0, and it cannot be plus or minus 2. Or we also call those the excluded values, the values that x cannot be. Okay? All right, now try number 3. Once again, you may want to pause and try it on your own. So factoring each piece, we have a 3 we can factor out here. And then in this second fraction, we have x plus 1 and x minus 1. So that means they already have this x minus 1 in common. But this first fraction needs to be multiplied by the x plus 1, while the second fraction needs to be multiplied by that 3. So we get x times x plus 1 minus x times 3 over 3 times x minus 1 times x plus 1. So let's start simplifying that numerator. So x squared plus x minus 3x over 3 times x minus 1 times x plus 1. And lastly, let's see, we have x squared minus 2x over 3 times x minus 1 times x plus 1. Now, I can tell in that numerator, I can factor out an x. And then I have x minus 2. But is that going to help me simplify anything? No, it's not. So you can just leave it without factoring that numerator. If you do factor it, it's fine. Okay? But you can also leave it if you know that when you're going to factor it, that nothing's going to cancel out.